All right, today we are going to be able to use the Pythagorean theorem to find the missing side of a triangle. So Pythagorean theorem says that in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the legs. So we just need a quick reminder. The hypotenuse is the side that is opposite of the right angle. This is the hypotenuse. And then this side is a leg and this side is a leg. The legs form the right angle. They make an L for the right angle. It doesn't matter which one is A or which one is B. These are interchangeable, but C always has to go on the hypotenuse. And the Pythagorean theorem is A squared plus B squared is equal to C squared. So we're going to be using some square roots and some squares to solve these problems. So the first thing that you have to do when you want to find the problem is you look at the problem and we want to solve for x. X is a missing side, and we notice that we have 2 of the 3 missing sides. So we automatically know that we want to do Pythagorean theorem. So we need to find the hypotenuse first. That is the most important thing to find. Find that hypotenuse, and the hypotenuse in this case is 13. So that's our hypotenuse. That is our C. Then the other two, it doesn't matter which one is which, a squared or b squared. So I'm going to do x squared first plus b squared. A squared plus b squared equals c squared. Now, there's a couple of ways that you can process through this. You can let the calculator do the work for you. So I'm going to do x squared is equal to, we're going to subtract, we're going to move that 5 squared to the other side and do 13 squared minus 5 squared. And then the way that we undo or we inverse a square is a square root. So squares, that's a square, x squared, and then there is a square root. So if we take the square root of both sides, then that will give us what we're going to type into our calculator. So we can go to our calculator and we can type in the square root. The square root key is right here. It's on top of the squared button. You hit shift or the blue key and then the squared key to get the square root. Square root of 13 squared minus 5 squared. Type it in just like that, and it will give you the answer. And in this case, we don't need to round out nice and pretty as 12. Now, another way that you could do it if you like, and this is really important, you're going to do this in pieces, is I can take x squared plus 5 squared is equal to 13 squared. Order of operations says that you square them first, so x squared plus 25 equals 169. 5 squared is 25. 13 squared is 169. Now subtract 25 from both sides. So 169 minus 25 is 144. X squared is equal to 144. You are still going to take the square root of both sides even if you do it this way. So we take the square root of both sides, and then so you type in the square root of 144 is 12. So either way, you get an answer of 12, whether you do it all in one step on your calculator or whether you do it in little mini steps, whichever one you need to do. So again, we need to find the hypotenuse. So we find our right angle and then we go opposite. So our side that is opposite, this is my C or my hypotenuse. The other two, it doesn't matter. I always like to write my variable first. So x squared plus 5 squared is equal to 10 squared. If you want to do this all in one piece, then you would have x squared is equal to 10 squared minus 5 squared. And you can take the square root of both sides. So if you like to do it that way, you can do it that way. Or you could say x squared plus 5 squared is 25 equals 10 squared is 100. It's a good idea to know up through 15 off the top of your head. It just makes life go a little bit faster and you don't have to use the calculator not quite so much. X squared is equal to 75. So now take the square root of both sides. Just like always, anytime you want to undo a square, you need to take the square root. And we're going to take the square root of 75, and we get 8.66. It says to round to the nearest hundredth. So the hundredths place is the second 6. We're going to look one number behind it at the 0. The 0 is not going to impact the 6, and so our answer is going to be 8.66. You would get the same answer if you did it all in one thing, 10 squared minus 5 squared, all in one step. So whichever one you're comfortable with, don't take shortcuts that don't work for you. Okay? So now we look at this. Now be careful, because the way that this triangle is turned, it can be confusing. We kind of try to get into a habit where we always use the right side or the left side, or whichever side, the top side, is the hypotenuse, but that's not always the case. Find the right angle and then look opposite. That is the hypotenuse. This is my C. So in this case then, I need the hypotenuse. So I have a squared and b squared. It doesn't matter which one is which. So a squared plus b squared is equal to c squared. Now, if you'll notice, everything is already on the same side, right? We don't have to move anything over. We can just take the square root of both sides. But if you want to do this in two pieces, be careful with this right here. This 2 root 3 squared, I can get it to focus again. There we go. Sorry about that. So 2 root 3. So we're going to do, it doesn't like the, sorry about that. It doesn't like the glare, I think, on the calculator. So 2 root 3, so the easiest thing to do is to type in the 2 root 3 like this. So type in 2 times the square root of 3 on your calculator and hit enter. Okay, just hit enter. Then hit squared. So that is 2 root 3 squared. So 2 root 3 squared is 12. Plus 2 squared is 4 equals c squared. 12 plus 4 is 16 is equal to c squared. Take the square root of both sides when you get down to the end of it, and the square root of 16, so you can see it, is 4. You could also do the 2 root 3 all in one piece. Do it in parentheses. 2 square root of 3, close your parentheses, squared. Oh, it didn't square the whole thing. So 2 square root of 3 squared. That's why it's better to just type it all in. There you get 12. That's why it's better to just type it in, hit enter, and then square it at the end. Now on 4 is a little tricky. We're going to use stuff like this when we get to area at the end of the year, but I want to know x. So what you want to do is you want to break this in. Anytime you see a right triangle, you're more than likely going to need something from that right triangle. So what I do know, though, is that the top of this is 9. That's 9, and that's 9. This is a rectangle. So I also know that this side is 9. If I knew the lengths of each of these triangles, then I would know the entire base. So I'm going to break it in, and I'm going to step aside for just a second, and I'm going to find out how long this is. I'm going to call it B. I know it's a right triangle, so this is my C, my hypotenuse. So I would say b squared plus 5 squared is equal to 13 squared. You could say 5 squared plus b squared, it doesn't matter. So if we do this in pieces, b squared plus 25 is equal to 169. Subtract 25 from both sides. You get b squared is 144. Which means b is 12. Now be very careful. That's not the question I asked you for. This is 12, which means that over here, this side is also 12, because these two triangles are exactly the same size, 5, 13, 5, 13. The same calculation would give me the 12. So if I take 12 and I add 12 and I add 9, I find out that the entire length of the bottom of that trapezoid is 33. So it's just another way to see that right triangles don't always exist like on their own by themselves. Sometimes they are a part of another shape. Now, one of the things that's nice about Pythagorean theorem is there are certain numbers that always seem to show up, and they're called Pythagorean triples. So a Pythagorean triple is a nice shortcut, and it's just a shortcut. If it doesn't work for you, then don't do it. But the most common triples are these. 3, 4, and 5, 5, 12, and 13, 8, 15, and 17, and 7, 24, 25. Now what this means is if I have a right triangle and one side is 3 and one side is 4, if I notice that and I know my triples, then I can, without having to think about it, I can say, well, then that side is 5. The hypotenuse has to be 5. And in fact, if you go back up here to number 1, notice that I had 13 on the hypotenuse and 5 on the leg. Well, if I have 13, and if I have a 5 and I have a 13, and they're all in the right place, the 13 has to be on the longest side, I instantly knew that that was 12. I didn't have to do all of that work. But you can see, if you don't remember the triple, you can do the work. So these are just a nice shortcut that you can use to help not to have to do quite so much work, because these come up a lot, particularly in this class. Okay, so here's some practice. Let's find the perimeter of this triangle. So here's the perimeter. Here's a little trick, right? We don't want to use the distance formula. The distance formula is a lot of work. So let's look at this. So notice, I'm just starting with this small side, no particular reason. So I'm just going to draw in, see this nice little right triangle right here? Well, that nice little right triangle has BC as its hypotenuse. Well, what I notice is that this has a length of 3 and this has a length of 4. Now this is where that Pythagorean triple comes in nice and handy, because if you know your triples, then if that's 3 and that's 4, you automatically know that that's 5 and you don't have to do anything else. You don't have to do any work. You just know that BC is 5. And I want to find the distance all the way around the triangle. That's what perimeter is. All right, now let's look. I've got this AB. So I'm going to go my horizontal and my vertical. So now I'm going to use this right triangle right here to find out how long AB is. So this side is 1, 2, 3, 4, 5. This side is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I happen to know that there's a 5, 12, 13 triple. If 5 and 12 are the legs, then that means that 13 is the hypotenuse. Now, so far already, we have been able to shortcut this problem, right? Because I didn't have to do anything because I had those pieces that were Pythagorean triples. Okay, so let's test this one and let's see. Again, we're going to draw in our right triangles because we know how to do Pythagorean theorem, and that's so much easier than doing the distance formula. Because if you do the distance formula, there's more room to make mistakes. And so I get that all in, and I know that I want to do my Pythagorean theorem. Pythagorean theorem is a squared b squared c squared. So AC is the longest side of that triangle. This side is 2, and this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's 16. Well, I don't have any triples that have 2 or 16 in them. And so this one I actually have to do Pythagorean theorem. So what I can do is I can say a squared plus b squared is equal to, we're going to call this, let's call that x, equals to x squared, or AC squared, right? You might see it written like this sometimes, AC squared. So 2 squared is 4. 16 squared is 196. Let me double check that. Oh, no, it's not. It's 256. I'm sorry. 256. I'm glad I checked. Equals x squared. Do the math that it says, right? 4 plus 256 is 260 is equal to x squared. Take the square root of both sides. The square root of 260 is 16.12. So that is this length. Remember, going through the whole thing, we did all that work just to get that one side. See, that's why those triples were nice, because we could have had to do that 3 different times, but we didn't have to because we knew our triples. So it says to find the perimeter. The perimeter is all the length all the way around. So the perimeter would be 5 plus 13 plus 16.12. So we take our 16.12 and we add 18 to that, and we get that the perimeter of the triangle is 34.12. Okay, that's where those triples come in handy. Now, one of the favorite types of problems that we have with Pythagorean theorem is word problems. So we have a baseball field. A baseball field is a square, and each side of the square is 90 feet. Now, with word problems, always in geometry, convert them. Okay, now since it's a baseball field, I'm going to draw it kind of like a baseball field so that it looks right. Here's home plate, first base, second base, third base. And it's a square, so each side of the square is 90 feet. So we're going to go in and we're going to label it. During a double play, the ball is thrown from third base to first base. Okay, so from third base to first base. How far is the ball thrown? Round the answer to the nearest tenth. Well, because it's a square, I know that all of these are right angles. As soon as we see that right angle, we split that square into two right triangles. So two right triangles means I'm allowed to use Pythagorean theorem. So we're going to look just right here. You can use either one, but we'll use this one. We've got that little right triangle. So the distance from first to third base is my C. That's my hypotenuse. It's the longest side of the triangle. So I'm going to do A squared plus B squared is equal to C squared. Do the math. This is 8100 plus 8100 equals C squared. So 16,200 is equal to C squared. Take the square root of both sides because you need C, not C squared. Take the square root of 16,200. And you get 127.279. It says to round to the nearest tenth. So the tenths place is this 2 right here. We're going to look one number behind it at the 7. The 7 is going to round the 2 up to a 3. So we have 127.3 feet. Right? And that is what C is. So that is the distance all the way across from first base to third base. Okay? So imagine this in your head. A 15-foot ladder is placed 5 feet from the bottom of a building. How high up on the building will the ladder reach? So imagine you've got a building and it's sitting on the ground. Okay? And it's a 15-foot ladder. So imagine you've got a ladder. Here's your ladder right here, right? Can you kind of envision it? Here's your ladder. Okay? And it is placed, it's 15. The ladder is 15 feet. So let's put the 15 foot on the ladder. It is placed 5 feet from the bottom of the building. So the bottom of the ladder is 5 feet from the bottom of the building. So there's the bottom of the building. So this side right here is 5 feet. How high up on the building will the ladder reach? So what we are looking for is this right here. How high up the building? So you can call it whatever you want. I'm going to call it H for height. You can call it whatever you want. So this is a right triangle because hopefully that building is at a right angle. It's supposed to be, which creates this right triangle. So we can do Pythagorean theorem. So we know that the ladder is the hypotenuse. It's the longest side. That's one way that you can do a quick check. Because if you end up with, getting a measurement that's longer than 15, something went wrong. Because 15 has to be the longest measurement. So we would do A squared plus B squared is equal to C squared. So do your math, right? Your squares come first when you're doing Pythagorean theorem. So 15 squared is 225. So 225 minus 25, you get H squared is equal to 200. Keep going. So you got H squared. I don't want H squared. I want H. So I have to take the square root or the inverse of both sides. And the square root of 200 is 14.14. It says round to the nearest foot. So the nearest foot would be the 14, the 4. So we look one number behind it. The 1 doesn't affect the 4. So to the nearest foot is 14 feet. So the ladder is going to reach approximately 14 feet up the building, which makes sense. It has to be shorter than 15. So you can always double check and make sure that that makes sense. The last one about how many feet of fencing are needed to enclose a rectangular garden with a 50-foot long side and a 60-foot long diagonal. So we don't have a picture. This is geometry. We always need a picture. So let's draw a rectangular garden. Go back about how many feet of fencing. So feet of fencing, we're looking at going all the way around the fence, right? We want to go all the way around the garden. We want to keep the rabbits out. So we're looking for perimeter. That's what we're looking for. Are needed to enclose a rectangular garden with a 50-foot long side. It doesn't matter which one you put it on. A 50-foot long side and a 60-foot long diagonal. Diagonal goes from corner to corner. That's a 60-foot diagonal. Okay, so in order to find the perimeter, I need to find the missing sides. Well, I know that this side has to be 50 because it's a rectangle and opposite sides are congruent. So I need to know this length right here. I'm going to call it x. So I need to find out how big that is. Again, this is a rectangle. Rectangles have right angles. When I drew in that diagonal, I created this nice little right triangle that I can use Pythagorean theorem with. So x squared plus 50 squared is equal to 60 squared. C is your 60, the hypotenuse. So I have x squared plus 2,500 equals 3,600. Okay, solve for x. Keep going, so you subtract 2,500 from both sides. You get x squared is equal to 1,100. The square root of 1,100, take the square root of both sides. Square root of 1,100 is 33.16. Now, you have to be really careful here. We're going to keep just 166 right here. So you have to be careful because I want you to see that it's not in this particular answer choice, but it is always a possibility that that answer will be an answer choice to make sure that you're paying attention. The question said how many feet of fencing are needed to enclose the garden. That means that this is 33.2 feet and this is 33.2 feet. So I'm going to take 50 plus 50 plus 33.2 plus 33.2, or you could just do 33 since it, and you get 166.4. So the closest that we have is 167 feet all the way around. Okay, so that is about how many feet of fencing, because since we want to round to the nearest whole number, we need to round up to make sure, because if we buy 166 feet of fencing, we won't have enough. So we got to round up to 167 in order to have enough fencing when we get ready to put it together. So Pythagorean theorem is a squared plus b squared equals c squared, where C is the hypotenuse and A and B are your legs. And you write down the formula, set it up, and then solve. And in the end, you take the square root of both sides so that you can find out what the answer is.